Okay guys, now let us talk about Simpson 1/3 rule. Okay, now the formula for calculating or solving the integral numerically using the Simpson 1/3 rule. The formula is I is equal to P minus A x0 plus 4 summation of I, where I is 1, 3, 5 and so on. That means odd values of I, and minus 1 fxi plus 2 into summation of j 2, 4, 6 even values of j fxj fxn. Okay, sorry, I'll write it down here. Where is this? Just write it down here. Divided by 3 into n. Okay, again when you talk about the step size, it's going to be b minus a divided by n. Formula of step size remains the same, and when you talk about x, the next point is going to be x0 plus m into h. Okay, so rest of the formulas remains the same. Okay, so now let us solve this problem using Simpson 1/3 rule. Okay, so let us first talk about single application. So basically what we are doing here is we are just applying it once. Okay, so understand, whenever in the problem number of step size is not given, number of segments, not step size, the number of segments are not given, for Simpson 1/3 rule you have to assume it as n equal to 2. Okay, so when n is equal to 2, I is equal to b minus a integral of x0 plus 4. Let us talk about now n is equal to 2, so this is going to be starting from 1 to 1, so it's just going to be x1. Okay, and n is equal to 2, so this is going to be 0, so there won't be anything here, divided by 3 times of n, where n is equal to 2. That comes out to be 6. Okay, so again I will start with the table first. We'll talk about xi, fxi. Okay, so let us talk about x0 first. So x0 is nothing but a, which is nothing but minus 2. The next point is going to be x0 plus of h, when h is the step size. So let us calculate the step size. Step size is going to be 4 minus of minus 2, that comes out to be plus 2, divided by the number of segments, so this is going to be 6, that comes out to be 3. So x1 is going to be what? x0 plus h, and that comes out to be minus of 2 plus 3, comes out to be 1, and then x is going to be 1 plus 3, that comes out to be 4. Okay. So when you substitute these values of x, okay, in f of x. Now what is f of x? As we have already seen in other problems, this thing is f of x. So you have to substitute the value of x in this equation, and when you do so, you'll find out the value of f of x that you are getting is minus of 29. This is going to be minus of 2 and 1789. Okay. So what you are going to do here is you are going to substitute the value of b is 4, a is minus 2, fx0 is minus of 29, f of x1 is minus of 2, and this is going to be 1789, and this is going to be 6. So when you calculate this integral, when you substitute all the value and when you calculate this integral, the value of I comes out to be 1752. Okay, and when you calculate the percentage true error, the error comes out to be 58.7%. Okay, now remember from the past lecture when we applied the trapezoidal rule, okay, with the single application, there the percentage error was what? It was 378%. Okay, now if we can just recall, let us go back and check again. I think we solved it somewhere here. Yeah, so what was the percentage error here? 378%. 378%. And the error that you are getting by single application of Simpson 1/3 rule, you can see it's 58.7. So you can see such a big difference. Okay, and as you can recall, the difference between trapezoidal rule and Simpson 1/3 rule is that we replace the function, the complicated function, by a higher order polynomial. So when you talk about Simpson 1/3 rule, we replace it by a second order polynomial. So you can see just by changing it to a second order polynomial, the percentage error reduces to like 58.7%. Okay. Now let us move on to let us apply Simpson 1/3 rule for n is equal to 4, and let us compare and let us see what happens. Okay. So again, when you take n is equal to 4, the formula for I becomes b minus of a f of x0 plus 4 of x1 plus f of x3 plus 2 of x2. Okay, if in case you are still not sure about how I got this, just substitute the value of n is equal to 4 in this general formula, and then you will be able to get this value. Okay, this is going to be 3 divided by n, 3 into 4. So let us first calculate the value of h, the step size, b minus a divided by n. So this is going to be 4 plus 2 divided by 4, that is 6 divided by 4, that comes out to be 3 by 2, that is 1.5. Again xi, fxi, okay, x0 is going to be minus 2, it's nothing but equal to a. Then x1 is going to be minus 0.5, x2 is going to be 1, x3 is going to be 2.5 and x4, there is nothing but xn, is going to be equal to 17, sorry, it's going to be equal to 4. Okay, you just have to add 1.5, 2 plus 1.5, 0.5 plus 2.15, 1.5, 1 plus 1.5, 2.5 plus 1.5, and so on. That is the step size. Okay, so now we have discussed how to do this many times. So I hope now you are clear. So from next time onwards, I'm not going to repeat how to find out these values of x0, x1, x2, and x3. Okay, and again, when you substitute this, you get the value of fx minus 29. This is going to be 1.9375. This is going to be equal to minus 2. This is going to be 131.31. Going to be equal to 17889. And when you substitute these values in this formula, the value of I that you will be getting is 1144149. And if you see, the percentage error comes out to be 3.6%. So as you can see, when we took n is equal to 4, okay, in trapezoidal rule, the percentage error that you were getting was 37%. But now if you see, the percentage error you are getting by applying Simpson's 1/3 rule is 3.6%. Okay. And similarly, I'm not going to solve this, but when you do it for 8, 10, and so on, the percentage error is going to reduce, and for n is equal to 8, the value of I comes out to be 1106.52, which is very close to 1104, and the percentage error comes out to be 0.2%, which is very good, which is very close to the analytical value. Okay, so this was Simpson's 1/3 rule.